Welcome everybody to the October 10th Robot Builders Night Virtual of DPRG. We're going to talk robots and have community. So our first speaker is going to be Pat. Lead it off, Pat.
Hey guys, I have tonight an update. I don't know if everybody can see my screen.
Yes.
I have a compass working on my robot.
Good, good.
After trying several different MPUs, IMUs, to try to get a compass that actually works fairly well. So far, I don't have my motors running on it yet. We'll find out hopefully this week with some motors running if it holds up. But in the bottom window, I don't know if everybody can see, it's jumping around a little bit.
Yeah.
But I have a heading, so approximately right around 0. And if I give it a spin, 90 degrees, my heading changes to 90. I can't go that way because I run out of cable. Go back this way. So I spun it about 180 degrees, and I think that's metal in the area in the printer that's touching it. I'm at 162, and I point it to the west. I'm at 250 roughly, and then back to the north, I'm close to 0 again.
Okay. Well,
so I'm picking up some iron somewhere. There's a whole pile of metal all around it, so I know that I'm being affected. But I can spin it around, I can move it, and I can go back, and I'm at least getting numbers reliably repeatable in all directions everywhere I turn it, which is something I haven't been able to do. That is using a LSM 303 IMU. So it's an accelerometer. And
who's the maker?
That I'm not sure of. This one came from Amazon, so it was made in China.
Aren't they all?
Yeah. So I've tried 6050s, I've tried BNO 55s, I've tried everything. This guy here, right out of the box, so I'll give you a perfect example. So I'm at 240 degrees. If I stop it, and then I restart it, which will reset the Arduino, I'm back up at 240 some degrees. With the BNO, I would be at 0 degrees.
Nice.
And so that was one of my problems with trying to work with the BNO 55 is that I had to start with the robot facing north all the time. And this guy here seems to be, no matter which direction I start him in, he seems to pick it up and go with, I would say within 10 degrees right now where I'm supposed to be.
Pat, was there an Arduino library package available for that device?
Yeah, so I have, I believe it's a Polulu library.
Okay.
Polulu, I think, used to make this sensor available. I don't know if it is anymore. I'm using LSM 303.h as a library.
Yeah, I just looked it up, Pat, and it looks like Adafruit makes a breakout board, and they have a library also.
Adafruit did. I tried the Adafruit library to work on it, and unfortunately I could not get it to work. And reading around, I found the Polulu library, and this one here was very, very simple to get going, basically.
I had volunteered last week to talk about my digital compass experiences from a couple of years ago. I can do that later this evening if there's interest. That
Okay.
might be very apropos with Pat's success.
Okay, I'll put you on,
Yeah.
Tom.
Okay.
So I've got some other stuff to work on. I've got a voltage divider working. I've got still working on my servo pan and tilt for my camera control. It's not on there yet. I do have my volts working on my battery. So I'm plugged into ground to shore power, essentially, not off the battery right now, off an adapter, and I've got 11.7 volts roughly. So that is working. I have 2 of the Sharp IR sensors we discussed last week, the analog 20 to 50 centimeters, and they are working. I find they tend to bounce around a little bit, but so far, so good.
Hey, Pat, how much are they bouncing around? When you say bouncing around, like a couple of centimeters, or are we talking?
Oh, like I see on there typically anywhere from plus or minus 10 centimeters.
Okay.
Like I find that they're quite unstable. I've tried a couple different filters on them to filter them out.
Yeah.
Creating some filters, averaging them, doing a few things, throwing away, out of the last 5 readings, throwing away the low and the high reading, and I've tried all sorts of stuff, and nothing seemed to smooth it out really much. Right now, I do have a filter on it, and I keep 20% of the new reading and 80% of the old reading.
So one thing you might want to try, and I don't know if that's still necessary with the newer versions of the sensor, but on older versions it was highly recommended to solder a not large, but like a 10 microfarad electrolytic capacitor for decoupling directly to the sensor, right? Not somewhere else on your circuit board. And I don't know if I can show this, but I've modified all of mine that way, and it did seem to help. So
Let's
literally
see.
directly on the sensor, there's a little, where the connector goes in, there's a small little circuit board, at least in the model that I have, the older model, and there's room and there's pins where you can solder a capacitor too, and that was recommended, and it seemed to help.
Was that across the analog output and the ground?
No,
or
it was
that
across power, so it was because I read that, well, people were saying that because every time it sends out an infrared pulse, right, for doing its measurement, it's kind of a power surge, and you need that capacitor very close to the sensor to deal with that power surge.
And that was a 10 microfarad?
I think you should Google it. I don't remember.
I'll see if I can find an application note on it.
Again, there may be, I know there are newer versions of this, so it may also depend on what version of the sensor you have. But it's just a keyword for you to Google and see if people are saying that's still necessary.
Okay, I'll take a look at that, because I was surprised a little bit on how much it was jumping around.
Yeah, it should not be jumping that much, no.
No, when the image in front is static, and I was starting to wonder if it was bouncing off like my door behind me and the glass or something like that. But when I point it towards the wall, like right now, the left is aimed at me and the right is aimed at my monitor, and it seems to be fairly stable, but it's still like as stable as it gets, and it's still bouncing around like 10 centimeters.
I want to say that I know David has used them extensively, and I've seen his readings, and they don't bounce like that. They can be pretty stable. So I think Chris is right. I think that IR pulse probably is dropping your line. That'd be fun do you have an oscilloscope, Pat? I don't know if you do or not.
I don't. My oscilloscope is so old that all of the pots on it are full of dust and everything else now, and that it's unusable.
Okay. Well, I'm just saying it'd be fun to see if you really would. I was doing some teaching, and I was using servos, and I was trying to get across that, you can use a little servo on an Arduino board if that's all you're doing, but what's really happening, because it's, when that I'm not saying, excuse me, sonar sensor, when it pops that sonar pulse, there's a big old ka-chunk on the line, and something you need to know. And same thing with the servo too. So anyway, that's cool. I'm hoping that idea, you might, because that 10, it might even be 100 microfarads, I would think. It could be. Can you look at one of yours, Chris?
Yeah, I'll do that. I'll do that and then put it in the chat. I'll have to dig it up. I think it's in the basement. I'll do that.
Okay, cool. All right. What else, Pat?
That's it for me. So
Question.
Yeah.
Go ahead.
So the setup you had with Visual Studio, and maybe you mentioned that on the call that I was not on, but I see you are remoting into something else to SSH. So what's your Visual Studio code connected to? Is that like a Pi, and then the Pi is connected to the Arduino device? So what does your setup look like?
So just bringing it back up. Yeah. So I have. Where's this guy? So this guy is remoted into a Pi at the bottom, SSH. So I'm running SSH remote on the Pi, and he is running in there. And then what I do, because I'm running two Pis or two Arduinos on my robot, so I have one of them mapped out to dev TTY sensors, and I use that in my Visual Studio Code so that I can find the correct port. And if I can drop back to
so that Arduino is connected to the Pi.
That Arduino is connected to the Pi, definitely.
Okay.
So,
and so you do the downloading. So you build your Arduino application in Visual Studio Code using Platform IO, and then you build and you download it to that Arduino.
Yeah. So I'm doing that. Yeah, exactly. So basically from SSH. Right now I'm on my work computer, but I do it from my home computer, my laptop, and I'll SSH into the robot with Visual Studio, and I do my download from there.
Yeah.
And I don't know, can I get a terminal window in SSH? Yeah, terminal window. So.
All right, so that's on your Pi. And what are you running currently on your Pi? What version of OS on flavor and so on?
I'm running Bullseye on the Pi.
Help me out. So, that's the one on the 3, right? That's not.
That's it's running on a Raspberry Pi 4. It's Bullseye.
Okay, is that the new one then? The Bullseye? Is that the newer?
That's the newer version, yes.
Okay, all right.
I'm running 32-bit, not 64. And you can see my two Arduinos tied there, TTY USB 0 and TTY USB 1.
Mm-hmm.
And I map those to dev TTY USB motors and dash sensors. And I don't know if I can bring it up enough here. I think it's 99. So Arduino TTY rules to map those out. And so I use a couple symlinks.
Mm-hmm.
And basically subsystems USB, and then I use the kernel's path to the port, to the USB port. And I remap that with a symlink to TTY USB motors. And what that does is what that does basically is, like I said, gives me a symlink to two Arduino boards so I can reliably program the right Arduino board from remote. And then in my platform.ini file, all I need to do is supply the port. So it comes in handy for programming the different versions. I did have a problem, by the way. This guy here is not an Uno. He's a Nano. And it seems like Platform.io has trouble programming to a Nano. I don't know why. And one of the workarounds was to just declare it as an Uno.
So, Pat, just to clarify, you're connected to the USB ports on both of your Arduinos?
I'm connected. My Arduinos are connected to the Raspberry Pi.
Using the USB port on the Arduinos?
Using the USB port on the Arduinos, and yeah, basically.
Perfect. I like that a lot. That's nice.
Yeah, so I do that, and my communication to and from my Arduinos is all stereo, essentially.
Sure.
And then you have your master logic on the Pi.
I have master logic on the Pi. I'm thinking about switching. I wanted to run a robot in the Robo Columbus this fall, but I won't be able to. Unfortunately, I've got a couple work engagements during that time. I'm still trying to get a video together if I can get this thing rolling and put everything together to get it moving and at least try to reach one cone.
Get you a mug.
Trying. So this has been working pretty good remote over at usually using Visual Studio Code, remote SSH. So what I've
that's over
installed,
Wi-Fi, I'm assuming, so your Pi is on Wi-Fi.
Yeah, the Pi is on Wi-Fi. I've got Platform.io, and I have remote SSH installed. And basically, you just tell it to go find you add a host, and then you just tell it to go connect to that host and give it a password, and off you go.
Have you tried the Copilot yet? Plug-in?
No, I have not. I have not tried.
You should try it. I mean, it's, yeah, I know, maybe that's, we can talk about it. And everybody's done talking. Maybe let's talk about ChatGPT. I want to know who is using it for what. So anyway.
Okay. So that's about it for me, unless somebody else has more questions.
Well, that's impressive. You have the
cool.
digital compass running, because I know how hard that can be.
Not really. If I can do it, any one of you can do it, because I'm just an electrician. You know, I'm not an engineer. I'm not a rocket scientist. I'm just a lowly electrician that's into automation.
Well, that's pretty cool. Hey, listen, Pat, would you be interested in writing up how you just very simple, how you put the scripts and stuff, how you hooked up your Arduinos to your Raspberry Pi through the USB, and I'll put it on the web. If you send me something, I'll create, I'll put it into the right format for the website and put it up there for you.
Yeah, I could do that.
That would be, I mean, that's a type of, I think that's something that a lot of people would like to know how to do. And they probably, we could get that. It'll bring some people to our website. We need to build our tutorials and stuff, because a lot of times it's very hard to find this stuff later on, Like Chris went through last year a wonderful talk about how to basically strip down the priorities of the different things to get where you're almost a real-time, or you probably are a real-time kernel. And I know it's out there, and I could probably find it with Google search, but it would really be nice to have that all organized in one spot. So Chris, if you wanted to do that, Oh, we'd love that too. You know, that was a lot of good information.
And we all enjoy writing documentation, don't we?
Oh yeah.
Welcome back, Chris. Here's a job for you to do.
Oh yeah, that would be.
I could do that, Doug. I'll try to put something together this week.
Yeah, that'd be great. I mean, things like that. You know, I can. You know, I'll try to format it up and get it in there, and so you don't have to do. You know, just write it the way. You know, just present it in a way that makes sense. You know what I mean? And then I won't be doing a lot of editing. So, you know, but I will do spell check and crap like that and whatever, you know, to get it up there. It's publish it.
Okay.
It'll be you'll be listed as the author, but the post will be by Robbie Robot. Yeah, all our posts are by Robbie Robot, so you know.
I'm fine with that.
Yeah.
I'm fine if Robbie Robot wants to be the author as well.
No, you'll be the author. We want to give people credit where they give it.
Do you also want to know the procedure to find the path and put in the sim links for the?
Yes. Everything. Yes.
Okay, so I'll put it as two. Well, I could put it as two posts.
That's fine.
Because the one to get communicating with the Raspberry Pi, I can do that in one, and then I can add another one for putting a sim link to use in Platform IO and Python or whatever.
Right. You probably want your platform. What do they call it? What is
Platform IO?
Is it the configure file? What is it? The one you showed it. It's platform.
The platformio.ini.
Yeah.
So yeah, I'll just create basically two separate little files.
Okay. All right.
I'll send those to you.
Great. That'd be fantastic. So next in line was Ray. Let's see what you got.
Okay. I have been working with, let me go to present mode here. Present. Ooh, this is different. Tab to share. Entire screen. Okay. It's a device. This is it's a 24 gigahertz radar distance sensor. So, and it looks like this, and even though pretty much all the variations of this board have the same number printed on them, they can be quite a bit different, and code-wise work very different. This kind of goes through, this is the DF Robot website, and that's their variation, which is, it looks identical to this, but it doesn't function the same. So this is supposed to be good for up to 20 meters. It looks like for large objects, like the side of a step fan, it'll find something at 20 meters. Smaller objects, it doesn't seem to find them as well. It's got a 48-degree horizontal sensing area and 23-degree vertical area. So it's kind of a broad, flat sensing area. The pinout was right, but the code was totally different. So I found, just searching, found the code. I thought this one had the option to work in like single distant output, which this would have been the format.
Yeah.
3 FFs, upper byte, lower byte, 3 zeros, I think was that one. Let's see, was that one? Okay, bytes. Yeah. Anyway, that was not the case. This one also talks about an output with spectral lines. That's not the case either. Anyway, so you can, there's a different version of this where these are actually spectral lines, and you kind of take the peak between, kind of the start and the end, with an arbitrary threshold of how big the line is, and that's the distance that your object should be at. Anyway, you can work it at 5 volts. You can work it at the outputs are actually 3.3 volts. So that was pretty good. I made, let's see here. A little board. This is with a cutie pie on one of Seed Studio's boards. It's got a little OLED LCD, and it's got a bunch of the I think on theirs they call them Grove ports. You can hook it up. There's a battery connector on the end, a little white connector. I'm running it off 5 volts off a battery pack. This thing. Mm-hmm. That works pretty good. Anyway, took it outside, and I know at Steve's place I ran into trees, and I had kind of minimal obstacle avoidance, and that's why I want to try to incorporate this thing. I certainly don't need something that goes out 20 meters, but I doubled the battery voltage on it from last year. I was only using I think actually it was a 4S, so I'm up to the voltage that the motors can actually run at, which is 22 volts. A little odd, but 22 volts. So it's going to go a lot faster. So it might be like ramming speed and don't want that. So I wanted something that could look out a little further and hopefully avoid it. So coming at an angle to building, and I'm assuming the or the placement of the cones is going to be similar to what it was last year. I don't know if that's realistic.
I have no idea. Yeah, I don't know what Steve's doing out there.
What's that?
Steve may have some construction going on, so there may be totally
it may be different. Huh?
Maybe real different. I don't know. I haven't talked to him about that.
Yeah. Anyway, so I just wanted something to avoid trees. It looks like I think it's actually reflecting off the water in the tree, because these are used as human presence sensors as well. There's a mode that you can get those to work like that. So hopefully Steve's trees are well watered, and they're make good reflectors. It does well off the side of a brick wall. Measured that pretty accurately. Anything metallic, I had actually the inside of a water heater that I use to burn stuff with. I call it my Burning Man. Anyway, it detects that really well. It's a cylinder that's probably, I don't know, 1.5 feet, but 2 feet in diameter. Big steel cylinder. So it detected that well. If you stand in front of it, it'll it seems to detect human bodies, or at least water in my body, I guess, fairly well.
So we have to be careful and watch Ray, because he may be leading his robot around. Okay, we got it.
Oh yeah. Well, it's not directional at all. I mean, the
Yeah.
beam is, or the sensing area is 78 degrees wide,
Yeah, I know.
and it doesn't tell you at all where it is in that field of view.
That's amazing, the way those things work, though. I mean, I took some of the guy with the Swiss accent tried some
yeah.
experiences a couple of years ago with one of those. And
Yep.
there was like a buck, he said, and tried it, and you put it in a room and it doesn't see anything, but as soon as a person walks in the room, exactly, you know that he's in the room. You don't know where he is, but you know he's in the room.
In the room. Yeah.
In the room.
Yeah.
Yeah, it's amazing.
Ray, did that one work while moving? Sorry, Doug.
Yeah, go ahead. Jump all over me.
Yeah.
'Cause
Yeah.
I-
Its update rate's 10 hertz, and
Yeah.
yeah, it seemed like if I kind of steered it around, moved it back and forth across, an object, it would find it. So
It's weird because all of them I've seen, typically, they don't detect anything except motion.
yeah, there's some that can do though. Humans, without human detection without motion. And I don't know how that's different. They just say they're FMCW. They don't really explain it any more than that. And a lot of the stuff is a rough translation from Chinese. So I think maybe that's the secret sauce of, how you get it to work. But anyway, I got this one on Amazon. I didn't get it from DF Robot. And so it does seem to work pretty good. I'm not, I'm going to stick it on the robot and see if it does any better.
Can you put your Amazon link?
Yeah, put the link.
I'm going to ask Steve for a ground crack report because my little caster got stuck in some of the cracks in his ground. So I can't really stick a bigger wheel on the current platform, but it could stick two casters, like, almost in line, so that, if the front one is going across the crack, the back one, or vice versa, may, keep the thing from getting stuck in the crack like a spike, because that's what happened last year. So that's relatively easy to do. And I've already got the casters and stuff. I just have to drill some additional holes. Like I said before, I've also increased the battery voltage. So I was, I think Doug's thing was, can you get it to go any faster? And so it's a lot faster now. So,
okay.
But with that, I have to, I think improve the obstacle avoidance because I don't want to wreck the thing, slamming it into something at high speed. So.
Can it get through the bocce ball field?
Might. I don't know. Oh yeah. The other thing is it was a little front heavy, and going down the slope, it, at one point it tipped a little forward.
Yeah. And
so with the weight of the two batteries in the back and the extra caster in the back, I'm kind of hoping that that's going to keep it from, tipping forward on the really, steep slopes that Steve's got on his yard. I don't know how he mows that thing. He must like sit in his mower sideways, and mow it, not downhill, but across the slope or something. It's a pretty good, pretty good grade to get, go down.
Yeah, it is. It has some. It does have some rough terrain. Plus, there's a few washed out gullies. Luckily, they weren't in the path this last year, but there are a few places that it just literally your robot would drop out of sight, and that'd be the end of it.
Like I said, I may give him a call and say, okay, what's the terrain looking like?
Yeah. Okay. So where did you get your code, Ray, that you got to work? That wasn't clear to me.
It's been a while. Let me present. I don't actually remember where I got it. I know that I played around with it like over a year ago.
Yeah.
I think I just looked around until found something that worked, because the what DF Robot had and what other websites had wasn't close at all as to what this thing is set up to do. So this is the code. It's just radar single target, and it's these are the outputs where
you're not actually
numbers here where I'm
Ray, you're not showing your code. You're not showing your code.
Oh no. Oh, okay.
No.
What did I do here? Stop sharing. Oh, okay. Let me try that again. Now, window. Okay. Oh. Share. Okay, can you see that?
Yes.
Okay. Anyway, so this one's totally different. It'll output, well, it at least matches what the description was in AliExpress, but I couldn't get any code off of anything that they recommended that actually worked. This one will output up to 5 distances. So here's distance 1. These are in centimeters, so about a little over 2 meters. Distance 2 is a little over 3 meters. Same thing with distance 3. And distance 1, the first one, that's supposed to be the closest object. When it does get close to something, these numbers seem realistic, at least. I didn't get out of I don't know what it would be, a metric meter stick or something, like the equivalent of a yardstick, and actually measure it or something, or tape measure. But so that's and when it doesn't see something, it kind of shows numbers like between 2 meters and 3 meters. So when it actually gets down below kind of like the 2 meter mark, I know that that's a realistic measurement. I'm assuming the other things are just things that it's seeing bouncing around the room, some measurement of something, I don't know what, but not anything that seems like it should be measuring to me.
Okay.
But when I get closer in, it does seem useful. So it looks like under 2 meters, it's usable. And that's all I really need. It's not going so fast that I need to look 10 meters ahead or something. So if I can't get this to work, I'm going to go back with a LiDAR light and actually stick it on the servo and scan, because I know that works outside. I've tried that, and that gives good distances, and it
Ray, if you look at your software window, and you scroll up to line 0, up to the top, is there like a comment or anything that might give us a hint to how to find the source code?
Where it came from?
Yeah.
No.
Okay. All
Nothing.
right. Okay. All right.
So it's like I said, it's been over a year ago.
Yeah.
I tried to look for the same source. It seems like it disappeared. I don't know where it came from, but I'm glad I got it when I did, because this is the code that works with my unit, and or at least the version that I bought. So.
Do you have the Amazon link or something that you could share?
Yeah. Oh, sorry, it wasn't Amazon. It was AliExpress.
Oh, yeah, AliExpress. Okay.
Okay, come on up. Things are slow in computer land here today. Come on. AliExpress. There we go. Can't.
There's
Yeah, this that was the other thing I tried to look this up. This store doesn't even exist anymore.
That's fine. It's got to have
Yeah.
something on it, you know.
Okay. Well, it just comes up as sorry. The page you requested cannot be found.
Yeah.
So.
Amazon does the same thing. Okay.
Yeah.
All right. Well,
Yep.
then I don't think we'll be following in your footsteps.
Yeah, unfortunately.
Yeah.
Anyway, so
I'm real interested to see if you get it to work.
yeah, it's kind of it's got a lot of nice features. It doesn't, not hurt by moisture in the air or wind or,
Hmm.
too much ambient light. It's kind of impervious to all that stuff. So, here's hoping that it's going to function well on a robot. So,
Okay.
anyway, that's all I had.
Okay. Well, then I guess the next one on the list is me. And what I'm going to, you all know that because of some circumstances out of my control, I haven't been able to put as much time on this as I would like. But one of the things that I had deemed last year after my problems with my robot was that I was not going to use an Ackerman steered robot this year. And there's a lot of, I have a pretty good software base that I think I could modify fairly quickly, but the building an appropriate chassis was going to be my big problem. So this week I was able to put some actual time on the robot, and so here's what I've come up with. This is one side, okay? So here's a 37 millimeter motor, millimeter motor, and there's two bars. These are just placeholders right now, and there would be two of these. So one for the left, one for the right, and there will be a platform in between which we'll use to hold the battery. And literally the whole top deck of my other robot will be removed and then placed on this one. So the idea is now I'll have a differential drive motor, or at least that's what I'm hoping. So you might ask, well, okay, so if you look in here, it's going to be belt driven. You can see that I have a couple of pulleys in here. I'm using a temporary shaft right now because I have to press because of the bearing fits and everything, I have to press everything together. And there will be another one of these, I guess they're called cogs, will be up here on the motor shaft, and another one, there'll be another shaft between here. So one of these will be going back, driving the two motors, and one will be going up to this motor and driving the two motors. So anyway, this is what I came up with during the week in the time I could spend on this. And I've got all the 3D pieces printed out, and this is what here's what the actual shaft is going to look like. And this is the tire I'm going to use. So what I've done is, this is a Vex wheel that I happen to have around. So I took their, I don't know what size, whatever size shaft they use.
5-inch wheel?
Huh? This is about a
5-inch?
5, yeah, I think it's 5.
Yeah. Looks like about 5.
Yeah. I'll move my ruler around. but they use a little square shafting thing. So what I did, I can get my ruler here. Get this. Well, maybe not. Oh, there it is. So they have a collar that fits on, and then the wheel slides in and out, and you can see what I've done is I've drilled a hole that was pretty much a press fit, and it's a round hole, and then I pressed their little steel axle piece back down into it.
Square shaft.
Yeah. So that anyway, that's where I am. It looks like it's going to work out okay. A couple of things.
So did you weld it?
No
or
welding. There's no welding.
Just press fitting. Huh?
Yeah, right now. If I have to, I'll put super glue down in there.
Okay.
But I don't right now. It's not like, oh, it went in easy. It's more like, oh crap, finally got it in. So I'm not thinking that I'll have much problem with that.
Yeah.
And these are all, the print bot we hit, the printer bot we turned into an art bot back a couple years ago, Ray.
Yeah.
Well, I finally tore it all apart, and this is some of the rod from that. So it's recycled. So anyway,
So just to clarify, so your robot will have 4 wheels,
yes,
and you'll drive all 4 of them with 2 motors,
right.
Yeah.
and then you'll differentially steer it because you've got a drive system on each side.
Right, exactly.
Gotcha.
Okay.
How far apart will the wheels be? Have you thought about that?
Well,
Across the width of the robot.
Give me a
It's
second.
supposed to be square, according to.
Yeah, the ideal is square, but mine is right now. If it makes it to the competition, that's it. The wheels are right now. I've got them set at about a foot apart. All right, axle. So that's 2.5 inches. On each side if it's a 5-inch wheel, which since I found my ruler I can tell you. But I think it is a 5-inch. Yeah, it's a 5-inch. So they'll be about a foot apart. Now I say that because I'm using these 2020 extrusions to simplify the design by. I'm going to have a belt that you notice there's no belt tensioner on it yet. Yeah. I'm hoping I can get away with simply sliding these out to tension the belt.
Mm-hmm.
All right. Otherwise, I can just move these further apart. So it might be 12.2 inches, to get it. Yeah. And likewise with the one that goes from here down to here, around this guy. He'll have he can obviously just be moved along this rail to tension up the belt. Yep. So that's what I'm looking for. I haven't I didn't want to guess the size of the belt, so I went ahead and bought some non-closed loop belt, and at the worst I'll use this to measure and get a more accurate measurement of what I need, and then I'll just order the belts. But we'll see how it goes. I'm hoping to be able to just buy closed belts. These are 10 millimeter belts. That's what I'm shooting for. So they're a little beefier than the 6 millimeter belts that you see around. Yep. And if you guys will be patient, I'll be right back.
So you're gonna do a Frankenbot then? You're gonna take the head off one and stick it on the
Yeah.
body of the other, right?
Right, yeah. So if you look at this guy, you can see underneath here, there are 4 3D printed brackets that hold this top deck. Okay, and the top deck is got pretty much everything on it except the battery holder. So I can undo these 4 screws up here, and I've already taken out the pie to do some other stuff. So, but they'll just lift this off and then put it on top. So these what did I do with it? Oh, this guy here, if you can think of it, might be sitting like, kind of like this, underneath the robot. And there'll be another one on the other side, flipped around, obviously. So there'll be 2 of these. And so they may not fit this guy perfectly. They may be wider than that, but I'm hoping to be able to use these extrusions themselves to put the brackets that go up to the superstructure. But anyway, that's the idea. So I'm trying to try to figure out how to convert to a differential robot base without losing everything that I had done before. So we'll see how it goes. You know, there's some obvious things I'm giving up. Those probably aren't the ideal wheels. They're also not going to have any suspension, which, you know, it's not a cool thing. But suspension is not going to happen this year for sure. But if I could get this where it would actually run, that would be an exciting. And we've reached, I think, what is it?
Yeah.
It's the 18th, so we've got a month and a week.
Yep.
Yeah, so it's doable if things don't get in the way, but things are getting in the way, guys. I'm not as being able to put as much time on it as I would like. Yeah, so, but we'll stagger forward. See how I want to see if I can at least get a point this year. You know, I've been designing these mugs and not getting any of them. So I really would like to get one. Oh, by the way,
you can keep one back.
no. So I wanted to show you the final design of the mug. I think this thing will do it. Let's see here, competitions. Yeah, okay. I don't know if it'll blow up or not. No, I guess not. But do you guys see that? Are you seeing a mug?
No.
No? Okay, give me a second. Got to figure out what's going on here. No? No? Come on, Doug. Oh. Now I'm lost. What are you guys seeing?
See you.
Okay, you're seeing me, so I'm not sharing. That's what it is. Okay. All right. Give me a second. All right. Okay. All right. So what I'm going to do here is do the entire screen and do a quick share. Share. Okay. And oh, wait a minute. It should be able to just do this. Do you see it now? There
Yep.
in the middle. So that's the final version of the thing. You can go. It's obviously you can find it at DPRG Columbus 2.3 under the competition.
Can you zoom it in a little?
Oh God, I don't know. Let's see. Yeah, I guess so. Well, I said I could.
Except
your privacy. Now all I see is a cookie policy.
Yeah.
Ah, there you go. Very cool.
Look at that.
Yeah. So yeah, it's a little fuzzy at this. You know, it's very sharp when you see it. But there we go.
Is that a Dave Anderson creation there?
Well, at the time I tried to. It's kind of Dave's, but it's kind of a combination of 2 or 3 robots that were around at the time that I designed it. The person that's helping me with this did last year's, which had this. This is she doesn't do. This is not a drawing. Robbie is actually a model. Okay, so she can pose them around and use them next year or do whatever he wants with them. The same thing with the robot. So that was the robot from last year, I believe. So anyway, it's cool. All you need is 1 point. I'm going to stop sharing now.
Ted, how
Wait,
is,
you telling me
how's
you've
your
never
platform
gotten a
going?
point before?
No, I have gotten points. I've actually done, I've actually had 4 or 5 points, but
Well, then how do you not have a mug?
because it was
That
before
was
we
pre-mug
did
times?
pre-mug times. Yeah.
Pre-COVID, pre-mug. All right.
Yeah. So I don't have a mug, but I'm hoping to get one this year. But like I say, this may not be my year. We'll see. So maybe next
Well,
year.
we could reward you for all the hard work you've done for the club.
No, I don't want
Like
that. I don't want no pity.
Honorary
I don't want no
Yep.
pity mug.
Then he's going to have to come up with a whole honorary mug design.
Yeah.
What's that?
Honorary mug design.
With gold laurels
There you go.
around it and sparkles.
Maybe we could change the rules, and as long as your robot rolls.
No, well, we
We have that.
Not a complete brick. Yeah.
Yeah.
Give
Yeah.
it a point for getting off the starting line.
Yeah. Well,
There you go.
like I say, what I'd like to see is, I think 1 point is a reasonable goal
Well,
for
that-
everybody.
How many mugs do you have on order?
Well, I order them at the end. So like if you
see.
get it, it's a printable type thing. I send it out, and I don't even see the mug. It goes directly to you.
Yeah. Wow.
Hmm. So, yeah, that's it. And the club picks it up. And there will probably be some prizes, but the prizes, guys, it's too much work for me to try to hassle these guys to give prizes. So what we have done in the last couple of years, and I know a lot of people haven't taken advantage of it, but what we do is, I'll send out an email that says, well, if you won first prize, you've got maybe $50 plus $10 shipping. If you're second prize, we got $30 plus $10 shipping. And if you're third, you get $20 and $10 shipping. And you can buy from Adafruit or Pololu or Spark Fund or whoever. It'd be nice if you could buy it from Pololu since they sponsored us so nicely in the past. If I were to, so that's how we've been handling it in the past. But I know a lot of people who just said, I don't need it. But whatever, it's yours. If you won the prize, you're qualified to get it. And if you have any problems with the prizes, let me know because I'm not the treasurer, so I don't do the reimbursement. You have to send a receipt to Steve, and Steve will send you the money. Anyway, 5 weeks. Ted, how's it looking? Are you going to come on down?
I'm still hoping to come on down.
Okay.
I was working on my robot with the fancy suspension.
Yeah.
And having all sorts of problems. So at this point, I decided to go back to what I did 2 years ago.
Yeah.
And I'm fixing that up, and adding to the code, so I think that's a better plan.
Yeah, yeah. I know what
Maybe
you mean.
one of these years we'll get the suspension working a little better.
Yeah. My dream would be that a group of us would go up to Seattle during one of their Robo, what is it?
Magellan.
Magellan,
Yeah.
Robo Magellan.
Yeah.
And since they broke up their rule set so much this year, so they have, like, you know how we just say, well, if you get a point, you get a mug, and we have, you can get three points per cone. So, you know, the idea is a person would build their skills and get more points. They're doing it a slightly different way, in that they have something like what our old Robo Columbus was, which would be go out to a cone and come back. Actually, our old Robot Columbus was even simpler than that, was just go out to the cone. But and then they have one which is like a big square. I'm not sure how that one works, but where your robot drives around in a big square and comes back to the original starting point. And sort of like a big, you know, I don't know if it's like 100 feet on the side or 100 yards, or I have no idea. And then they have their classic Robo Magellan, which is it's at least as challenging as ours, and probably slightly more. Yeah, depending on how they set it up. Shybots out of Chicago used to run the same contest, and the classic one, and they had a lot of nice videos. If you just want to see robots running, trying to do a Robo Magellan, the Shybot video archives are really nice. But they lost their website somewhere, and to be quite honest, I don't know if they've survived COVID.
Really?
Yeah, I don't know. And I know that for a while there they kind of disappeared, but they were still on the web. You just had to kind of like search for like Shybot, Robo Magellan, and you'd start getting YouTube links. So anyway.
You can often find that stuff in the archives as well.
Yeah.
The Internet Archives.
Mm-hmm. Yeah, that's a good point. You might be able to go back on Time Machine or whatever it is called.
The Wayback Machine.
Wayback Machine, yeah. Go back in the Wayback Machine and find it. Well, so anyway, my goal this year is to get to a differential robot. I think that's
all right.
That simplifies the problem so much.
Yep.
Yeah. So we'll see how it goes.
I don't know. I think with four-wheel drive, I don't know that, not unless your robot is going so fast it can harm itself by, catching air or something, In a lot of cases, the frames have some flexibility in them anyway. They're not like completely rigid.
Well, since these are two separate modules,
yeah,
there is the opportunity to spring the two. So that you could have some side suspension maneuverability.
Oh.
Okay.
Yep.
If you look at the thumper design, the six-wheel, 6-motor thumper design, it basically has a clip spring that holds the two sides together, and you're just actually pushing against that clip spring.
Oh.
So it's kind of at one time, again, this is something you can probably find on the web still. There was a great robot site, and I can't remember its exact name. Something like Build Robots or something like that. And anyway, they actually had the person who originally designed the thumper before it was picked up by whoever builds it now. And, it was, just a homemade robot. He built it And so a lot of the things that they did later got incorporated into it, but it was one of those fairly simple suspension, simple 6-wheel robot. Anyway, I'm more concerned that I might end up having to buy alternate motors. Ray, I might race you to the bottom when it comes to speed. I don't know. I don't know how fast these things are. Looking at them, I don't think these are spec fast enough. But we'll see. But we'll see. And I really don't know when I start putting all the weight on it. Will these guys handle that? So there's a lot of. You say, well, Doug, why don't you just engineer that and figure out what all that is ahead of time so you can design for it? I don't got that time. I just have to, if I get it built, and then we'll play around with it and see what we can do with it.
Yeah.
Yeah.
I was going to say, if it's probably pretty simple to do. It's kind of what they do on motorcycle back wheels. You have basically something that pulls it's like a washer that goes over the axle and pulls the axle back, so that you can counteract the chain tension.
Well, here like I say, you got this rail. You can just slide these further apart.
Right.
So that.
But yeah.
But what I'm
but
not.
If you have the kind of the washer, over the axle and a threaded rod and a nut pulling it back, it's pretty hard for the thing to slip forward.
Yeah. Well, if you really had that problem, you could put a T-nut block in front of it.
Oh yeah,
Okay,
that might work.
You could. There's ways I think around. I'm more worried about these guys are going around this. I don't know if you saw that, but it's not a very big. It's not a very big thing. So.
Hub.
Yeah, and it's going 12 inches out. So you might have things going like this when you start moving, where they're bouncing against each other.
Yeah.
So there might be there's a bunch of failure modes that could happen.
What's your final weight? What do you think it's going to be?
Oh, probably about 40, 50 pounds. No, I don't know.
Yeah. 200.
Yeah, let me put it this way. We'll put it together, and I'll try these motors and see if it rolls. If it doesn't roll, I have two options: bigger motors or less weight. I'd love to cut the weight down, but what my attempt was to try to prevent having to change. If I can use as much of the old robot as possible, that saves.
Well, the old robot's pretty light in terms of the control system. It has to be. It's sitting on a sprung suspension, right?
Yeah.
So it's and it's not a huge four-wheel drive. Is it a?
Yeah, it's a four-wheel. It's four-wheel.
Is it? Yeah. It's not huge, so that's got to be not super heavy. So the majority of your weight might be in your drivetrain itself.
Yeah, I agree. That's a good point.
And if you're only doing two motors, right?
Mm-hmm.
Then it's still it's nowhere near the kinds of stuff that my team is doing. So I was originally going to suggest you might want to look at like a 5mm pitch belt for the deeper teeth. So because if you're doing a 10mm wide belt, that's probably a 3mm pitch between the teeth, right? So the standard 2mm is the one that you see on most 3D printers.
Yeah.
And my team moved away from that to like the 3mm pitch, which is about 10mm wide. Or you can actually get them in 15mm as well. But if you've got a lot of torque you need to transmit, then I would suggest going up to the next biggest size, which is the 5mm HDTs.
Okay.
But I'm guessing it's not because it looked beefy the way you were showing off that 20x20 extrusion.
Yeah.
but
it's all motor weight basically.
it's this is mostly the motor's weight, right? Yeah.
Yeah,
So it's actually not going to be super duper heavy. So I think you can do the belts you're talking about should probably work out fine. And I know Vex and both Vex and Rev,
yeah.
as well as plenty of other vendors have closed belts in lots of different sizes.
Yes, there are closed belts.
Yeah.
I just didn't want to. To me, I just figured I'd try the open belt. I was concerned that every day is kind of important to make progress.
Yep.
So to have an open belt, I can literally measure it and say, okay. You could say, well, why don't you use a rope? Well.
Yeah, you can use a string or whatever, right?
But I'm just saying.
It's cool. Yeah.
I figured this way, if I had to make one myself, I could do it. You know what I mean?
Sure. Yeah.
If I
plus,
had
plus
to.
you have it for a linear slide mechanism if you want to. Yeah.
Yeah. And I might strip off to reduce the weight. Probably lose the sonar sensors because they don't seem to they don't seem to be reliable enough in the field, and so I might go to one just forward-looking, some sort of LiDAR sensor, and just see how that works. We'll see.
Throw it on a servo and just scan.
Well, probably just look forward, and if I'm not trying like Ray said, he's trying to avoid the trees, But if you remember the way Steve's yard is, around each tree is an area of unmowed prairie grass.
Brush, yeah.
Yeah.
And so,
Texas.
So I don't know if we got anything that'd be real super effective in finding that. Maybe the sonars might actually pick it up. They're saying, you're in the brush. Well, that's usually too late.
Well, those old Polaroid sensors, they're narrow enough they would pick it up.
Yeah, and they're a whole different.
That's a whole different difficulty level. Yeah.
Yeah, but they're also fantastic sensors.
Yeah.
They're really fantastic compared to these cheapy $2 SR whatever they're called.
SR04s.
Yeah. So anyway, we'll see.
So I did good keeping those old land cameras on my shelf, did I?
You bet. Those are great sensors.
Those are fantastic. Yeah. I would like. Yeah. We'll see. We'll see how it's going to go. So, maybe at the worst, I have a bumper on this set, and it was made pretty beefy because it was an assumed that it was going to hit something way too fast. So, otherwise the springs, all of the switches are protected by dead stop before the spring bottoms out and stuff like that. So we'll see. It's going to be a challenge.
Yeah, I realized I probably chose a pin that was too small, but on those worm and worm gear motors, I turned them down to 1/4 inch and then fit I think a 1/2 inch shaft over that and pinned it with a 1/16 roll pin, which is really just a piece of metal hardened steel that's kind of shaped into a round pin. It's hollow. Anyway, if I turn the motors on too quick, it would shear that pin off. So it's like, ooh, can't do that.
I don't think.
Or stop them too quick because it would just, snap it right off. So I think next time I do it, I might take a piece of broken drill rod or something really, solid and hard.
Yeah.
We'll see if it can, withstand
It
motor
will be
jerk or
interesting. Kareem,
whatever.
what's your experience with this size motor?
Yep. Can't hear you, Doug.
Oop. Kareem, what's your experience with these size motors? Are they beefy enough, or am I going to just stall out? Do you know? I don't know. You must have stepped away.
Yeah, some of those can have like a 7 amp stall or something, so that's
Yeah.
quite a bit of power.
Yeah.
What size motor is that?
37 millimeter.
Yeah, that's similar to what we're using. Yeah, they can depending on the motor, they can stall up to 11 amps.
Mm-hmm.
Mm.
They provide a fair amount of power. Again, I don't think that you're look at just from the deck that you were pointing at.
Mm-hmm.
If it's not going to get much heavier than that, then I don't think you're going to have a problem running two of those,
Okay.
unless you. I don't know, that really steep. That super steep grade at Steve's place, right next to the house.
Yeah.
Going straight up that, it might not, but that's not part of the course, I don't think. So.
You know, usually the first cone is made easy. You know what I mean?
Yeah.
So,
Do those motors, are they geared?
Oh yeah.
Okay.
Yeah. God, what are these people doing?
Tornado, fire.
Amber
Yeah.
Alert.
Yeah. Subscribe to Apple Pay. No. Anyway.
I think it'll be
the
fine.
The other thing that is a possibility. There's no reason why another one of these motors couldn't be put on the other one if you had to.
Yep.
You could run double motors here. So,
Yep.
I mean, that is a possibility, but I want to try and get away from it.
Will be the Tesla dual motor.
Yeah. All right. Enough. Tom was going to give us a presentation if he was up to it. Tom?
Okay, I'll share a window here somewhere.
Okay.
See where it is. Not showing up. Hold on.
Yeah, it looks like there's been an upgrade to Meet. Give you some options it didn't give you before.
All right. Just going to make sure you can see that okay. Everybody see that okay?
Yes.
Okay. This project started a couple of years ago. Not exactly my project, but I got asked to help put it all together and make it work. Someone I met decided he wanted to build something called a home-seeking compass for his wife, to give to his wife as a gift. The pirate in the picture is Jack Sparrow from Pirates of the Caribbean. He's holding a special magical compass, the compass that points to the thing that you desire the most. So his intention was to create a compass which you could give to his wife while she was away, which would always point home, no matter where she was actually away at. So he started looking for ways to build this thing and ended up asking me for some help. A little bit of background that might explain how we ended up with this, with the results. Brock, who's the guy that asked for the help, he lives near Ottawa. At the time of this project, his wife was living in Milan, Italy, because she was going to school there. Hence his desire for providing this gift for her at Christmas time. Now, Brock is a high school English teacher. He had received an Arduino dev kit sometime before, but never opened it. He has no knowledge of programming or electronics at the time he decided to create this magic compass. But he saw an instructable having to do with creating a compass that could point to geocache locations. He thought this would be an easy project. Of course, it was not an easy project for him. He started looking for some help. He looked for a couple of months in a wide variety of places, an Arduino Discord channel, which couldn't provide him much help. The Ottawa Public Library Maker Lab, which was shut down because we were in COVID 2 years ago. Went on to Kijiji, which is a popular classified ad and buy and sell site, looking for a contract programmer. He actually hired one, paid him a lot of money, but got no results out of it. Then he went and had a look at the local college, Algonquin College, where they have a robotics program. He talked to an instructor there to see if he could find a student programmer to help him. No such luck. Finally, he ran across the local Ottawa maker site, Hack 613. Got in touch with the website master, and that guy put him on the email list. So he started looking for help through the email list, and I noticed his pleas and thought it would be interesting. So started to learn some more about it. Now, Brock and I live a long ways away, about 5 hours drive apart. So all of the work we did was done over Zoom, a lot of Zoom meetings and a lot of emails. We ended up doing some compromises in what we ended up building simply because we were working with mostly parts on hand, because he lived out in the country, and everything that he didn't have but needed had to be ordered through mail order. And there's also a, shall we say, a substantial skills shortage in terms of what he could do. Mm-hmm. Brock eventually produced a video presentation on this project. I have it available, but I won't show it unless you ask me to. It's about 17 minutes long. It's mostly about his journey of failing and learning, along with the successes he eventually had. He also has a component in the video that talks about how to calibrate this thing.
Hey, Tom,
yep.
Can you throw the link to that into the chat?
I will if I can. I'll confirm it and see. He did the video on a presentation site that he used for his teaching work.
Wow.
And I'm not sure whether the link is public or how he set it up so I could see it.
Okay.
So I'm just not sure. I'll check later and see.
Okay.
I actually tried to download the video so I could play it locally if he wanted to see it, and was unable to download it. So there may be some security restrictions on it, which I didn't have the patience to figure out. There was a website called Loom, which I've never seen before. I've in the little map there, I gave you some indication of where I live and where he lives. We're about 5 hours apart. Curiously enough, Pat, you may recognize your neighborhood on that map as well. It turns out we're only about 6 hours apart. Pat lives up in the upper left corner of this map.
Okay.
I live just above where it says Manitoulin Island there.
Yeah, right about here.
Yep.
So that's about 6 hours drive from my house. So a very nice place. I've been there several times. Okay, so because we're building this project 5 hours apart from each other, or 5 hour drive apart, and we're doing it virtually, we actually built two. So this was the project as it looked at Brock's house. His intention was to build this into a very fancy presentation box, so you can see bits of the box here in its undecorated state. It ran with an Arduino Uno, used a small stepper motor to drive a compass indicator. Has a GPS in it. You see a GPS shield there in the bottom left. And it also had a compass, which is what we're going to talk mostly about. Just so that you can get a flavor for some of the interesting steps along the way, you'll notice in the lower right, inside the box, the compass is red, but the compass picture that I showed is green. That's because Brock had rapidly burned out the red one because it was 3.3 volts, and his Arduino, of course, is 5 volts. So that didn't go over too well with that particular compass, and we had to replace it. Also, depending upon how well you can see the diagram, those of you who are familiar with perf boards, as I suspect most of you are, breadboards, you may notice something strange about how that compass is plugged into that breadboard.
Yeah, all on the same.
Yeah. That was one of our first obstacles in troubleshooting. Brock's skill set did not include things like how to plug a shield into an Arduino. That was very confusing. And it did not include how breadboards work. So the learning curve was pretty interesting with Brock, working with Brock. The project at my house looked a little different. My container was a turned inside out grocery store cardboard box. And I have a little different compass. You'll see the compass sitting up here. This blue object is the compass I used. That's what we'll talk mostly about. So this was sort of the crux of the project we're working on. At the end, I'll show you what the finished product looked like. Now, the particular compass that I used is number 1 in the bottom left corner. It's a Honeywell HMC 5883, which I obtained from AliExpress and had sitting in my collection, waiting for a good excuse to use it. The fancy curve is an idealized magnetometer response curve from a classical magnetometer-based compass. This picture is taken from the Honeywell application note on their particular module. I recommend the application note as being a very broad overview of how digital compasses work. It doesn't have a whole lot of depth to it, but it's very easy to understand. This diagram, for those of you that have worked with compasses, you may recognize that this is highly idealized response. Real magnetic compasses or digital compasses do not look like this, as I found out in my explorations. The left-hand side of this page is the first web page from this particular article on how to calibrate a magnetometer. I highly recommend it for those of you that want to deal with these things. It's very well written, has good practical research material in it, and some examples and conclusions that are easy to understand. You can easily Google this using the title and then look for the article with the date. The picture will pop right up. What's most interesting about the piece of the web page I captured is the very bottom line. There is one problem, though. Magnetometers are prone to distortion. Boy, are they ever. We'll talk about that in a minute. Now, in order to implement this thing on an Arduino, I examined 6 libraries specific to this particular compass. Only one of those libraries did any calibration at all and didn't do it particularly well. So if you're going to attempt to work with digital compasses, check the available libraries very, very carefully. One of the libraries I looked at was pretty good. The others were pretty trivial. And I wouldn't recommend using them. And that includes libraries from the brand name suppliers. They are good as far as they go, but basically all they're intended to do is to make sure that you can connect the compass up to your Arduino and get some basic raw data out of it. And that's as far as they go. When you work with a compass or with a compass library, you need to consider how the software is handling the magnetometer amplifier gains, how it's handling noise filtering, and how it handles declination, if knowing true north is important to you. The calibration process generally involves capturing X and Y axis data from the compass while you rotate the compass through at least 360 degrees. You need to keep the compass level while you're rotating it at a constant rate. Pat, I don't know whether you go through a calibration process with your compass or not, but it's highly recommended for reasons you'll see shortly. Expect to gather a few hundred data points. Using those data points, you can use them to calculate offsets from 0 and what a reasonable data range is for each axis. Those things are useful when you're looking at the calibration of the data set to produce correct Gaussian data, and also how to set the gains if you're having problems with the amplifier gains that are internal to the compass IC. One suggestion that has come up in our work and in other work I've read about, sometimes the axis labels that are printed on the module printed circuit board are not correct. In our case, the compass that I worked with was correct. The compass that Brock eventually ended up buying and using was not correct. The X and the Y axes were switched. So we implemented a solution in the software because we already had code running by that time. Now, I wrote and added my own calibration function and diagnostics, which are available to anybody who wants them, rather than attempt to use the internal calibration process in the one library that had them, simply because I didn't think it worked very well and it hid everything. So you had no idea how it was calibrating. I also save calibration results in EEPROM inside the Arduino, which provides the option to the user in this final product, whereby if you didn't calibrate each and every time you turned the power on, the logic would simply use the stored values from the last time you calibrated. And most of the time that's okay. Any questions so far?
No.
So some results. These are early results from my learning curve with the compass I was using. The important graphs here are the solid colored ones, the red, blue, and yellow lines. Those are for the 3 orthogonal axes that are in these compass modules. And this is for 3 complete rotations of the module. Now these are kind of crude. I was sitting here in my swivel chair in my basement workshop, trying to rotate this thing with the whole apparatus sitting in my lap, connected to my desktop with a USB cable. That's not really ideal calibration process. Mm-hmm. Hence, the waveforms look a little strange. When you do calibration, it's useful, in fact, it's probably important, to keep the module level. You can see by the fact that the yellow curve shows variation that I was not keeping it very level. Also, there's peculiarities in the blue line. You'd normally expect these to look kind of sinusoidal, and the blue line has a dip in the first round and nothing later. I still don't have a full explanation of that, but it went away after a while. So it probably has something to do with the particular magnetic environment as I sit here at my desk. Also, the red waveform has a decreasing amplitude. Again, not explained, and it went away after a while. So I wasn't too worried about it.
Pat, excuse me, Tom, when you said it went away, do you mean that the decrease went away and it went to a steady state?
What I mean is that in successive tests, I did not see that same symptom.
Okay, gotcha.
So I don't know what it was. To be honest with you, this is early in my process of understanding these things. The various dashed lines simply reflect the peaks associated with these waveforms in this timeline or this sample line. As I was attempting to figure out what I could use to provide calibration data. Mm-hmm, mm-hmm. Pretty straightforward stuff. Mm-hmm. Now, once you get usable data, the Gaussian measurements, the magnetometer measurements, aren't really what you're after. What you want to do is pass them through some more math and calculate the azimuth reading or the compass reading. And that's on the left vertical axis of this graph. If you do not calibrate using data that I was collecting here in my basement, you get that yellow line. And that yellow line over 2 complete revolutions of my chair, that yellow line only varies from about 0 to 50 degrees. That is certainly not the full resolution of a compass. So that's where it became clear to me that I had a really big problem when I started to see those results without calibration. Calibration can be really important. These results probably vary. In fact, they do vary a bit from compass to compass. I had the experience of working with 3 different ones during the course of this project, although this is the one I did most of my work with. You tended to see similar problems with them all, depending on the environment you were in at the time that you were looking at them. Now, the blue line shows what happens when you do apply calibration to the raw data from the magnetometer. You get a lot closer to a 360-degree swing, even though, as you can see in this example, there's still a little bit of that dip, which is repeated a couple of times. The other curve that's on here is the green curve, and all that does is it shows what the difference is when you apply the declination value, the magnetic declination value, for the particular location you're at. Declination, of course, is simply the degree difference between magnetic north and true north at the location you're at. Where I live, it's about 12 degrees away from true north. So that simply shows the effect that has. It depends what you're trying to do with the device, whether it's important to apply that or not. Pat, do you use declination compensation for what you're doing?
I put it in there, but for most of the stuff I think we're dealing with Robo Columbus, I don't think it's that necessary.
Yeah, that's my conclusion as well. I put it in anyway in the final result, but we'll see where it went. Now, there's another way to look at this data that I found even more useful, and that is as polar curves. This comes out of one of the documents I referred you to. If you plot the x versus y axis instead of plotting along a sample line or timeline, then you get these circles. And the circles of the data, the raw data points and the corrected data points, make it really, really obvious what it is you're doing when you calibrate these things. It also gives you a flavor for what some of the other issues may be that you might or might not have to correct for. I did a little bit of research on what all the causes of distortion might be, and started to run into a lot of material covering the effects of what's known as hard iron and soft iron distortions. The compensation that moves the blue circle down to the red circle is generally considered to be compensation for hard iron distortions. That is, the things that tend to be relatively constant in the environment that you're in terms of magnetic distortion. The fact that the curves, that the dots tend not to always lie in the same circle, and that they may tend to have a bit of an oval shape to them, is often due to more complex distortions, which are in the literature are usually called soft iron distortions. There are many mechanisms, mathematical mechanisms associated with filtering those out. I didn't bother with any of that. It gets complicated in a hurry. And the pragmatists in the research I looked at said, if you have those kinds of distortions, what you should really try to do first is get rid of them. Make them go away rather than compensate for them. But sometimes that's very hard to do. So I found this to be a much better way of looking at what the effect of calibration is on the conventional digital compasses that I would use with a hobby application. Very, very interesting, very easy to see. The software I wrote simply collects all the raw data, which you can then look at through the Arduino development environment's serial plotter or serial monitor. I look at it in the serial monitor, capture the data set, throw it into a spreadsheet, and now I can analyze it in various other ways. So that makes it a lot easier to try and understand the mechanisms around compass operation and the compensation or the calibration you expect to do for them in order to get reasonable azimuth values. So some of the final results, the pictures on the left simply show the stages of development and the final product that Brock ended up with. He's a bit of an artist, so he's done some fancy decorating work on the top of the case that he had. The big round black knob is sitting on top of an XY analog joystick input. All that was really required in terms of the initial startup process for this device when you turned the power on was a push button. And Brock had push buttons in his development kit. But what Brock couldn't do was solder. We tried a lot of times virtually to get him to solder 2 wires on a push button and failed every time. So as you can see from some of the diagrams, virtually everything that he's put together is connected together with DuPont connectors, breadboard type jumper wires, which are from his development kit. And we made it work. And as it turns out, because we're now using a fancier input to the controller, we were able to do a few little extra things here that allows him to actually select whether he is using it as a magic compass or whether he's using it as an ordinary compass. He had a lot of fun with this thing. His video that he did showing how he calibrates it and uses it is a lot of fun. There's also one LED which is on the side of the box, which indicates what mode the particular device is in as you turn it on, as it gets calibrated, and as it gets a GPS lock. The pictures on the right, the reason why Brock did a video is because I had invited him to participate in the online virtual meeting back about, I guess it's a year and 3/4 ago in January, when I presented the digital compass stuff to the Vancouver and the Ottawa robotics groups. And I invited him to attend, and he could have his input as the end user in what he thought of all this. Unfortunately, that was exactly the day that he was going to be on an airplane carrying this gift to Italy to give to his wife. Hence the pictures on the right, where, as far as he was concerned, the final hurdle was whether he would be able to get this thing through customs and security as carry-on luggage. He did. He succeeded. Any questions? Any thoughts? No. If anybody would find the code I wrote for the calibration useful, by all means, we can figure out a way to get it to you.
Okay.
Very impressed.
Sounds very interesting. What sort of time period was this over?
Well, Brock started in September with his initial, what I call his Einstein process. The process of continuing failures leads to success. So he spent about 2 months working through everything else until he and I got together. So he and I started on this thing sometime mid-November, late November, and we worked through December and into the first couple of weeks of January. We had a lot of Zoom meetings.
Yeah.
Brock is a great guy to work with, acknowledging that he knew absolutely nothing about the technology that we were using. He hung in there. He was optimistic through the whole thing, and he learned an enormous amount by the time we were done.
I think it's rather amazing that you were able to accomplish it in that period, knowing how hard these things are.
Yeah. Yes, we not only had fun with the compass work, which was the first time I'd done a digital compass. I had played with digital GPS interfaces a long time ago, so I wasn't that worried about that. But the way GPSs work in terms of their physics was also a mystery to Brock. So we had a lot of fun helping him understand the conditions under which a simple GPS receiver works and the conditions that it doesn't work. We also spent some time, which I didn't see here. Thought I had another picture. No, I guess I didn't. We also did some work on establishing whether the compass, which points from Italy back to Canada, whether the computation should use a great circle line or a rum line. For those of you who might be sailors, the rum line is far more typical and is represented by a straight line on a Mercator projection. And that's what most people would expect if they were trying to decide if this thing was pointing in the right direction. They would compare it to the kind of map you can see on Google of the world, which is a Mercator projection. But the traditional method of determining distance, if you're flying an airplane or traveling across the ocean, is you're going to use a great line, a great circle computation. And when you're that far apart, the difference in the angle is really significant. I had a picture of that here, but I guess I didn't include it. So we ended up deciding that a rum line computation would be the same. We were going to add distance information as well. In other words, how far away is home? And that's something called a Haversine calculation. So that's in the code, but when we got to the point of discussing how he would see it, the whole concept of a display as part of this thing was just way, way, way beyond his pilot house. So we weren't even going to try that.
Oh, it's a good project.
I hope he wasn't being overly presumptuous in that this would tell her where her heart wants her to be.
We have to think positive about that. They're an interesting couple. One of the things that came out of this several months later is Brock's family. Brock was staying with his family, and they live basically the northern part of eastern Ontario. And they operate a farm up there. And one of the things they have on the farm is a sugar maple forest. So they operate a family sugar maple business, a little one. So around April, my wife and I get this heavy package in the mail, and it contains a quart sealer full of maple syrup made at their family sugar bush. That was very, very nice of them.
That's a sweet gift.
It was.
I thought maybe you were going to say, you know, his wife found somebody that looked like Fabio and got divorced shortly after or something. You know?
Well, it's their history is actually interesting. Brock and his wife were both trained as teachers in Canada. They're both from the Ottawa area. But they decided when they got married they wanted to see more of the world. But that's expensive. So what they chose to do was they began to take assignments in foreign countries doing ESL, teaching ESL, English as a second language.
Yeah.
And that worked out so well that they were able to spend several years moving from country to country and working for a semester teaching. And then they would save some money and they would travel some more, go to another country, get another job. And they did that for several years until they ended up in Italy. And that's when his wife decided she would switch careers from being a teacher to being a doctor. So she was accepted at med school in Milan, which is why they stayed there for several years. She's getting close to the end of med school. They choose to move back to Canada. So they come back here. She's still got a year to go. So they come back here, and he's basically getting a permanent job as a teacher and looking around to see where they'll live once she's done her med school work. So presumably they're both back here now. You're right. I don't know. I should check. I should ask them.
Who knows? Hopefully they are happily ever after. But
well, it was a fun project. I admit I learned a lot about digital compasses, but I usually do with these expeditions. Okay, any
That's
other
excellent,
questions?
Tom. I'd like to see your calibration, more info on your calibration and
Okay.
that sort of stuff.
Yeah. Now, if I may, I don't think you have any other way to get at my email address, so I'm going to send it to you in the chat, if that's okay.
Okay.
Okay. Let me just
Doug,
close.
can you pull it out later?
Yeah, I'll pull it out. I'll pull it out later.
Thanks, Doug. I'm going to stop presenting here. Stop sharing. And let's chat. So, Pat, just contact me directly, and anyone else who happens to be interested, just make a note on my email now. And then, Doug, I'd prefer that it not be in the permanent record, but
Yeah, I don't see it though.
there it is. There.
Oh, okay, I got it. Okay, cool. I won't even copy it into. It'll be here, but it won't be. Ooh.
Okay.
Okay.
Anybody who wants to know more about this, by all means, just drop me a line. And Pat, we can talk some more.
Okay.
Thanks.
All right. Okay. Right now I'm gonna stop recording, so that'll make it easier for me to. I didn't think about it. It'll still be in the recording, but I think I can edit it out of the recording. Okay, so I'm going to stop recording.